Hello, and here we are on section 4.2 with the answers to number 17 through 22. And these build up to the tougher questions. So the earlier ones are going to be things we can actually reason through and think through, and they'll start to help create the understanding of the formulas that we're going to use back here in 22 and then 23 and 24. So 17, let's look at that guy first. So almonds sell for $4.50 per pound. Cashews for $3.75 a pound, and peanuts for $2.25 a pound. Get cheaper and cheaper as they go on. What should the final price per pound be for a mixture that is 20% almonds, 30% cashews, and 50% peanuts? Now, we should note that that we're just looking for one variable, price per pound. That's it. So really, this is just getting us used to the idea of a weighted mixture. You can see 20 and 30 and 50 add up to 100%. So it's 20% of this price right here. So zero point 0.2 times 450 plus 30% of it is this one, 375, 3.75. And 50% peanuts. So that's 50% plus 0.5, 225. And there's not actually any algebra here. This is just tells us 20% that guy weighted, 30% that guy, and 50% that guy. And this is actually just like your grades, which we'll do over here in a moment. So let's plug this into our calculator and see what we get here. So we get 0.2 times 450, 4.5, plus 0.3, 375, and 50%, 0.5 times 2.25, 2.25. Ooh, we forgot a little multiplication symbol in there. That would have messed stuff up. So 0.2 times 4.5 plus 0.3 times 3.75 plus 0.5 times 2.25. And that enters $3.15. So that is the average of all of these. And notice it's not just we took that plus that plus that and divided by 3. That would have given us a 33% weight on each of these. This is called a weighted average. So $3.15 is the final cost of that mixture. And then they can sell it and whatever. Okay, so let's do number 18. Very similar. The grade of a course is made up of quizzes are 30%, homework is 20%, and tests are 50%. Now this is important when you're looking at a syllabus in a class and you see 30%, 20%, 50%. Tests are weighted heavier. They make up more of the grade. So we note that it says, what is the final grade of someone who averages 90% on quizzes? So up here, he got 90% of that 30%. And on homework, he got 10%. Horrible, that's terrible. But homework's only 20% of the grade. Let's see if it really damages them. 10%. That's terrible, but it's only 20% of the grade, and 82% on tests. So he has a B on tests, and they're half the grade. So what do we do with percents? He got 82% of that 50%. So if we multiply these, 0.3 times 0.9 equals a 0.27. And that's true. That 90% on that 30% means he got a total of 27% that adds to his total grade based on his quizzes. His homework is he got that 10% of the 20%. That only added 2% of his grade. So it went down 18% from what it could have been. It could have been, if he got 100% on it, he would have put 20% on his grade by that. And here he got 0.5 of 0.82, which gives us 0.41. If you add these up, you get let me see, 0.7, I think? Is that right? 0.70? Yeah, look at that, 0.70. So he ended up with a 70% in the class, C minus. And you can tell that's, I mean, the fact that half of his grade was at a B minus and 30% of his grade was nice, but he slacked off on the homework, took him all the way down to a C minus. Poor guy. Alas. All right. That's the idea of weighted grades. You take this 30%, 20%, 50%, and that's how much weight goes on each one. All right. So number 19, let's draw a little picture because we're going to be doing mixing solutions for a while, and so this picture is going to be very handy. So if we have this guy and it equals this final guy, they have different concentrations. So if they're filled this high and they have this much powder in the bottom, and this guy's filled up this high and it has a whole bunch of powder in it, and then this guy is going to end up being somewhere in the middle, but depending on how much of each one you put in, it's going to add up there. Okay, so here we have 10, let's do this in a different color, 10 liters of a 20% solution. So this is a 20% solution, and I have 10 liters of it. And 3 liters of an 80% solution, and that equals, it says, what's the concentration? So there's our X. What is the concentration of the final mixture? And this is where we need to understand that, hey, if you had 10 liters and 3 liters, we now have 13 liters. And so we actually figure it out by saying, hey, how much powder is in here? 20% of 10 liters. And how much powder is in here? 80% of 3 liters. And if we add them, that better tell us the exact right amount of powder in here, which is X% of 13 liters. Notice that this is not a system of equations. This is something that we can do just by hand. So this is 2 plus 2.4 equals 13x. Oh, I guess I didn't need to write that L in there, did I? So 13x, so we get 4.4 equals 13x. X equals 4.4 divided by 13. If we plug that into a calculator, 4.4 divided by 13, what is that? 33.8% is what it looks like there. 0.338 or 33.8%. And notice this is not exactly in half, in between 20 and 80, because we're adding more of the diluted concentration here. Good. Let's look at number 21. No, number 20. Let's do number 20. Sorry about that. So number 20. How much of a 35% solution should be mixed with 7 gallons of a 60% solution to create a 50% solution? All right, using this exact same bucket scenario, we're going to have 35% of a 0.35 of a 7 gallons, and let's draw our buckets here. Plus this bucket equals the final bucket, and we have water and some sort of mixture in there, water and a lot more powder in there, and we have water and powder. Okay, so this guy is a 35% solution. So the question is, how much of this? There's the question. That's our X. Should be mixed with 7 gallons of a 60% solution, and to create exactly a 50% solution. Oh shoot, do we have another variable here? No! Look at what happened. 10 liters and 3 liters added to 13 liters, so this is just an X plus a 7. That's how much we have. Notice this is still just one variable. This is something we could have solved back in chapter 2. This is 0.35 times X plus 0.6 times 7 equals 0.5 times X plus 7. Notice what that is. And notice that 30 and 65, they're not exactly, I mean, you're not going to add, 35 and 60. 35 and 60, you're not going to average them to get exactly to 50. So if you only add 1 gallon of this, it'll be really high up to 60%. If you had like 30 gallons, then you're going to have 37 gallons of pretty diluted stuff. So let's solve this guy. 0.35x plus 4.2 equals, jump that in, you get 0.5x plus 3.5. All right. So let's subtract, get the x's together, subtract 0.35x over here, and we get 0.15x. Subtract 3.5 over there, and we get 0.7. Divide by 0.15, divide by 0.15, and we get x equals, I have no idea. Let's pull the calculator out. 0.7 divided by 0.15, and we should get something like 4.666, 4.67. 4.67. Now notice this isn't a percent, our x was here. So it's saying that we should take 4.67 gallons, add to the 7 gallons we already have, and we'll end up with 11.67 gallons of exactly 50% solution. That's a cool problem. I like that one. Number 21 says 5 cups of what concentration? Let's draw our buckets. Good, equals the final bucket, and draw our little powder in here, draw our little powder in here. Oh, that's good. That just makes me feel better about what I'm doing. So we have 5 cups here of what concentration? We don't know what the percentage is here of how diluted it is. It needs to be added to 11 cups of an 87% solution, and we want it to create exactly a 70% solution. And this problem is going to be just like number 20, that 5 plus 11, 5 cups plus 11 cups better give us 16 cups. Oh, that was kind of nice. We didn't even have to add the x. So you'll notice this is still a one variable problem. So yeah, we have 5 times some solution plus 0.87 times 11 equals 70%, 0.7 times 16. And okay, so 5x plus, what does that equal? Better take out our calculator. 0.87 times 11, and that's 9.57 equals, and then 0.7 times 16, and that's 11.2. Good. So 5x equals, subtract 9.57 from that side, and we get 1.63. Double check, make sure doing that in my head didn't mess up. 11.2 subtract 9.57, and that gives us 1.63. Good. Now how do we solve from here? Divide both sides by 5. And 0.326. So divide by 5, and x equals 0.326, or 32.6%. And notice what kind of a question we just answered here. If you have 11 cups of 87% solution, you want to dilute it down to with exactly 5 cups, so you get 16 cups of exactly this, then you'll have to have this concentration to dilute this guy down to 70%. All right, so we need to look at and summarize, before we get into number 22, we need to summarize what is going on here. So let's clear this up and summarize what we have. Notice that you're going to have on this bucket here, when we do this bucket, and you have this much in here, and this bucket with this much in here equaling this bucket, we did the same thing each time depending on what our variables. We took the first percentage times this first volume, see this 20% of 10 liters or 35% of x, plus the second percentage times the second volume, and that equaled the final one, which was the percentage of the total volume of the total. Good, good, good. And then we also note that V1 plus V2 equals the VT. Always. 5 plus 11 equals 16, x plus 7 is x plus 7, 10 plus 3 is 13. Okay, now let's clear this off and do number 22. This is going to be a toughie. All right, number 22. Notice that right here we have, it's a little bit tougher. It says we have a 30% solution and we have a 65% solution, but it doesn't give us any amount of those. It says we're going to mix them and we want to get exactly 55% and 40 gallons of it. Now notice of this, how much of each do we need? This is 2 variables. This is a little bit tough here. If you have 2 variables, you have x of that and y of that. Now we're going to write our equations. Now we're going to get 2 equations. And so that's what you need to pay attention to. We have 2 equations. One of them is that x plus y equals 40. Oh, I forgot to write that up there. Volume 1 plus volume 2 has to equals the volume total. So x plus y has to equal 40. So let's write that down. X plus y equals 40. And then 0.3x plus 0.65y equals 0.55 times 40. Notice that's this equation right here. So you get one equation by just adding up the volumes, and a second equation by adding up the entire, like, the powder. Actually, you got 30% of X is going to be this much powder, 65% of Y is this much powder, and then 55% of 40 has to be the end result. So there we go. So the question is, should we do elimination, or should we do substitution? Look at this. This is our equation. We got it. I'm going to do substitution just because I'm kind of used to it. So I'm going to take and solve for y and subtract this x over here and do 40 minus x, and then put that guy right in there. So I'm going to rewrite it, 0.3x plus 0.65 40 minus x equals 0.55 times 40, and that gives us 22. This is an equation we can solve, and you could have done it by elimination as well. Jump the 0.65 in and we get 0.3x plus, what do we get there? 20, I better get the calculator out, I don't want to mess up on that one. 0.65 times 40, 26. 26 minus 0.65x equals 22. Subtract the 26 off and combine these two together, and we get negative 0.35x equals negative 4. Divide by negative 0.35, divide by negative 0.35, and we get x equals, oh boy, those will be positive, so we can just do 4 divided by 0.35, enter, 11.43 gallons. 11.43 gallons. Now notice that only answers one of the questions. That gives us this guy right here. They have to add up to 40. So if we subtract from 40, we'll now get that y has to equal 28.57 gallons. And that will be that guy right there. Excellent. 28.57 gallons, 11.43 gallons.